Well, it comes from Latin. You'll be shocked to hear. Latin, what does endo mean? Endo. Endocrine system. What are other places where endo pops up? And we have an endoskeleton. What?
Bone structure.
Sure. We talk about things endemic to our culture. They mean inside. Very good. You have an endoskeleton because your skeleton is on the inside. What's the opposite of endo? Exo. There are insects, for example, that keep their skeleton on the outside. I have an exoskeleton. And what does it mean for something to be symbiotic? What's symbiosis? Two things living together for both of their benefits. So the idea is that you had this case whereby it became a symbiotic relationship. It was beneficial to both cells. The inner cell had a lot of protection because there was a whole cell around it to keep it from being damaged by the outside world. And the outer cell had an advantage because there was DNA inside the inner cell that had this thing. And so its own DNA was less prone to attack from viruses, which is the main thing that attacks and damages DNA. And over time, the outer cell loses its DNA completely because the cell on the inside also had DNA, also had instructions to make a cell, and that was enough to do the job. So it's a mutual relationship.
Sure the DNA died.
No, I don't think DNA does a whole lot. It's just a line of code. So mitochondria are explained by the same process. Mitochondria are explained by the same process. You can imagine that we have a cell here, and it is now a eukaryotic cell, so it has a nucleus, and the DNA is inside the nucleus. And then you have another cell here, and this particular cell has its own DNA, probably also a prokaryotic cell, is maybe really good at producing energetic molecules. Maybe it's a bacteria that is really, good at running around energetic. When it was absorbed, again by phagocytosis, now we have a cell that has a nucleus, with its DNA, and has this second organelle down here that also has information in it. We have a bunch of evidence for this. The first is that mitochondria have their own DNA. It's actually neat. We always learn that your DNA comes from where? I made my own DNA? No, where's my DNA come from? Yeah, my parents, right? It's a combination of mom's DNA and dad's DNA, right? Like you took grade 9 sex ed, I'm sure at some point. You learned that, a sperm impregnates an egg. They form one cell. We call that a zygote. Those cells begin reproducing. You get an embryo, a fetus, and then that grows into. But one place where you don't get your DNA from both is your mitochondria. Every mitochondria in your body has DNA in it, and that DNA comes only from your mother. You see, sperm cells have no mitochondria, and when a sperm cell impregnates an egg cell, there's no mitochondrial transfer. So, your mitochondria were already in the egg cell that formed you, and that comes just from your mother. So your mitochondrial DNA should be exactly the same as your mother's. Her mitochondrial DNA should be exactly a copy of her mother's. We can track mitochondrial DNA, and the only reason it changes is by mutation, which happens much, much slower. And so we can track family lineage very accurately using mitochondrial DNA, because the DNA in your mitochondria come only from mom. They're passed only through the egg cells. Does that make some kind of sense? Kind of cool. So DNA, and this DNA gets replicated when new mitochondria are made. So a new way to think about organelles is they're almost like a cell inside of a cell. You know? They're almost like a little cell inside of a cell, but they've been designed to have, or they've evolved to have, specific tasks. The nucleus is a cell inside your cell, but it has the specific task of holding your DNA, keeping your DNA safe, replicating your DNA, reading your DNA as needed. And that's its only job. It doesn't have to do all the other stuff that the whole cell has to do. The mitochondrion, that's the one everyone knows, of course. What does it do? That's right. It phosphorylates adenosine diphosphate to form adenosine triphosphate. Very good, Ryan. But yes, it's the powerhouse of the cell. Its job is to make molecules that have lots of energy in it that your cell can then use to perform necessary tasks. What's another organelle in the cell?
Chloroplast.
Very good. The chloroplast. What's the chloroplast?
I only remember why mitochondria gets me into a lot of.
Oh, come on, this is the chloro. Come on, this is the one everyone knows. Oh, you're going to make me so sad.
No, the one everyone knows is mitochondria.
Okay, but this is one you should know too. So now we have a cell. It's got a nucleus. It's got a bunch of mitochondria. It stumbles on another little bacterium. And it actually stumbles on a really fun little bacterium that can do what? Why did I choose to draw this particular cell green? Very good. This is a photosynthetic prokaryote. So one day, one of our new eukaryotic cells stumbled on a photosynthetic prokaryote. And same thing happens. We get this engulfing, which, by the way, doesn't happen most of the time. Usually it eats it. But it only has to happen once successfully for us to get the formation of a new organelle. And in this case,